Hello, everyone. CNC machine tools in the factory and elevator in daily life requires forward and reverse motor. This task will use PLC control motor to achieve two-direction rotation. First, I/O address distribution. As shown in Figure 1, press button SB2, the motor rotates forward, press button SB3, the motor rotates backward. Press button SB1, the motor stops. Start button SB2, SB3, and stop button SB1 are PLC input instruments. Contactors KM1 and KM2 are PLC output instruments. I/O address table of PLC can be obtained. Input device is stop button SB1, function is stop, input relay is I0.0. Input device is start button SB2, function is forward start, input relay is I0.1. Input device is start button SB3, function is reverse start, input relay is I0.2. The output device is contactor KM1, which is used to control the positive rotation of the motor, and the output relay is Q0.1. ND the output relay is Q0.2. Second, PLC external wiring. The terminal L plus M is connected to a 24V DC power supply. I0.0, I0.1, I0.2 terminals are connected to the corresponding button and then connected to the DC power supply with 1M terminal. The terminal for L plus 4M is connected to a 24V DC power supply. Q0.1 connect with KM1 coil to the power supply negative, Q0.2 connect with KM2 coil to the power supply negative 2. The installation process is as follows. The specific installation process is as follows. PLC control peripheral wiring for forward and reverse rotation of three-phase AC asynchronous motor. Let's take a look at a good three-phase AC asynchronous motor forward and reverse PLC peripheral wiring. Three-phase AC asynchronous motor forward and reverse PLC control peripheral wiring. We have to complete the PLC power interface, input terminal circuit, output circuit wiring, respectively. We have to complete the PLC power interface, input terminal circuit, output circuit wiring, respectively. PLC power supply wiring. PLC needs to be connected to the DC 24V power supply. PLC L plus connected to the positive pole of the 24V power supply is also connected to the power supply of the plus V. M connected to the negative pole of the 24V power supply is also connected to the power module of the V. The L and N of the power module is connected to the positive pole of the 24V power supply is also connected to the power module of the V. The L and N of the power module are connected to the 220V power supply, ground-to-ground wiring. PLC input circuit wiring, input circuit of 1M to M. Combined with the I/O allocation, we need to stop button SB1, forward start button SB2, reverse start button SB3 were connected to the PLC's I0.0 to I0.2 and L plus constitute the input circuit. PLC output circuit wiring, PLC 4L plus connected to the positive pole of the 24V power supply, for M connected to the negative pole of the 24V power supply. Combined with the I/O allocation, we need to connect the two output indicators HL1 and HL2 to PLC's Q0.1 and Q0.2 at one end respectively, and the other end is connected to 4M to form the output circuit. Fourth, design the program. Forward and reverse are continuous operation. First design two program to achieve one-way continuous operation. Because two output coils cannot be connected at the same time, one coil branch is connected with another output relay normal close contact for interlock protection. Fourth, input the program. 4. Program input. Hardware configuration is carried out first. Double-click the TIA Portal software icon on the desktop to open the TIA Portal software, switch to Project View. Create a new project, project name, forward and reverse. In the project tree, select Add New Device. Click Controllers Somatic S7-1200 and select CPU 1215 DC/DC/DC, Article No and Version. Article No and Version. Click on Profinet Interface _1, click on Add New Subnet, set IP address in the project. Click Add New Subnet and set IP address in the project. For complex control systems that use a large number of input and output points, the use of symbolic addresses will improve the convenience of reading, writing, and debugging the program. You can write the PLC variable table before writing the program. Open PLC tags, add new tag table. Stop _button _SB1, data type bool, address I0.0. Stop _button _SB1, date type, bool, address I0.0. Start _button _SB2, date type bool, address I0.1. Start _button _SB2, date type, bool, address I0.1. Start _button _SB3, data type bool, address I0.2. Start _button _SB3, date type, bool, address I0.2. Contactor _KM1, date type bool, address Q0.1. Contactor _KM1, date type, bool, address Q0.1. Contactor _KM2, date type bool, address Q0.2. Contactor _KM2, date type, bool, address Q0.2. Input the program and click Program Blocks to open the main OB1 program editing page. Design two self-locking program blocks with normally open contacts and output coils, and set the corresponding addresses. Set the corresponding addresses and interlock them with normally closed contacts. After writing the program, click Compile to check the compilation information, and modify it if there is any error until there is no error. (5) Program Simulation Verification. 5. Program Simulation Verification. Start the emulation, do the program loading and start the module. Open the factory I/O simulation software and click on Start Simulation, which is equipped with Start and Stop buttons on the control cabinet door. Click Start _button _SB2, Q0.1 turns on, Q0.1 normally closed contact interlocks to Q0.2. Click Stop _button _SB1, I0.0 is disconnected, Q0.1 is disconnected, release Stop _button _SB1, I0.0 is connected. Click Start _button _SB3, Q0.2 turns on, Q0.2 normally closed contact interlocks to Q0.1. Click Stop _button _SB1, Q0.2 is disconnected. Click Start _button _SB2 to start operation. The conveyor belt runs positively and the material is transported forward. Click on Stop _button _SB1, the conveyor belt stops running. When Start _button _SB3 is clicked, the conveyor belt reverses and the material is transported backwards. Click Stop _button _SB1 to stop the conveyor belt. Practice. Here are some exercises for this lesson. The above content is how to use PLC to control motor to achieve forward and backward rotation, focusing on I/O address allocation, PLC peripheral wiring, program design, program input, and program simulation verification. Thank you all.